Yes, I welcome you all for another presentation on operational amplifier. Right? In today's presentation, we will see one more important question on inverting amplifier configuration of operational amplifier, which is asked in UPSC IES Indian Engineering Service Examination 2004. So this is the given circuit. Okay, this is the operational amplifier given. Okay, so the input is 10 volts is applied to the minus terminal of the amplifier, and whereas at the plus terminal the connection will be given like this. There are three resistors, 1 kilo ohm, 200 ohms and 1 kilo ohm. They are connected in this fashion and connected to this V0 actually. Now in this particular circuit, okay, we are asking that to find out IL. Okay, IL is the load current which is flowing through this 200 ohm resistor, right? We have to find out what is this IL flowing through this 200 ohm resistor. That is what the question. What is the load current IL in the given circuit, right? Our aim is to find out the IL. What should be done for this? How this IL can be solved? Very simple, very simple. Okay, so here let us say that at this particular point, let us imagine that some voltage V suffix A, let us imagine that VA is the some voltage actually, right? And apply your around that node, then you can apply the KCL equation, Kirchhoff current law. Okay, if you apply the Kirchhoff current law, right? So this is the zero potential actually. This is at zero potential. Obviously, it is 0 volt. And similarly, it is also ground is nothing but it is also 0 volt for this resistor. And for this resistor, the other end is V0 actually. Now, by applying KCL at this particular point, VA, then I can write like this actually. VA minus 0 by at this node, at node VA according to our KCL, right? According to KCL at VA, at node VA. So how I can write VA minus 0, VA minus 0 by it is 1 kilo, right? It is 1K plus then VA minus 0, VA minus 0 by it is 200 ohms plus, and then VA minus V0, because for this resistor one end is VA, the other end is V0, therefore the voltage difference VA minus V0, therefore it is VA minus V0 by how much? 1 kilo equal to 0. This is the sum of the currents at this particular node, clear? So therefore in this arm, in this 1 kilo ohm resistor, what is the current? That is V by R, means voltage difference. VA minus 0 is the voltage difference, V by R. That is what the current flowing through this 1 kilo ohm resistor. Similarly for 200 ohms, VA minus 0 by 200 ohms, that much is the current flowing through this, nothing but your IL. Similarly in this 1 kilo ohm resistor, VA minus V0, and you can simplify this, and this can be written as normally you can write VA by 1, right? VA by 0.2. If you convert this 200 ohms into kilo ohms, then it obviously it is 0.2 plus it is VA minus V0 by 1 kilo. If you write all are in kilo ohms, kilo, again if you convert 200 into kilo, it is 0.2, 1 kilo. So all are in kilo only, therefore I am writing straightforwardly like this. And from here you can write VA by 1, VA by 0.2, VA by 1 minus V0 by 1. You can rearrange this expression as VA, if you take the common, then it is 1, because 1 by 1 is 1, plus VA, if you take common, it is 1 by 0.2, clear? Plus again here VA by 1, right? Obviously it is 1, then definitely this is equal to minus V0 by 1, nothing but minus V0, that you can write on the right side, because minus V0 by 1 actually left side of this equal. That minus V naught by 1 is nothing but V naught only. Take that minus to right side, then plus V naught. And similarly, you can write like this: VA is equal to 1 plus 1, it is 2, plus 1 by 0.2. How much? 1 by 0.2. So if you change 2, it is 10 by 2, and obviously it is 5 is equal to V naught. This is the one expression we will get. Therefore you can write that. So 7 VA, or otherwise V naught is equal to 7 VA, 7 times VA. This is one relation we will get. This is the relation between output voltage V naught. This is this is equation number 1. You can call this as equation number 1, right? So by applying your KCL at this particular node, we are getting one equation between output voltage V naught to the nodal voltage. Let us assume VA is nodal voltage. Therefore, in between V naught to VA, we are getting this relation. V naught is equal to 7 times VA. Clear? Now, as per our virtual ground concept, that is another important concept that we need to consider. According to the virtual ground concept, the same this particular VA appears here also. Here also, VA. Write that the same VA will appear here. Now, for this loop, actually, for this, okay, for these resistances, you can write another expressions actually. Then I will write here. Very simple. Very simple. What you will get, and if you apply the same your KCL at node VA, then definitely 10 minus VA, okay, 10 minus VA by 1 kilo ohm, clear, is equal to VA minus V naught. VA minus V naught by 1 kilo ohms. Clear? At this particular node, if you apply KCL, okay, 10 minus means this is input voltage, 10 minus VA by 1 kilo ohm. That is nothing but the current flowing, this much current. This is the current actually, V by R form. I is equal to V by R. Therefore, I am writing that this current in this particular resistor, whatever the current flowing through this is equal to the current flowing through this. Means current entering, current leaving. That's what. 10 minus VA by 1 is equal to VA minus V naught by 1K. Therefore, both are KK cancel. And from this, what you can write actually, both 1 gets, then obviously it is 10 minus VA is equal to VA minus V naught. And from here you can write that if you take this VA to left side, that is nothing but then bring this 10 to right side. Therefore, if you bring this VA to here, it is nothing but minus 2 times VA, because minus VA is already there. If you bring this VA to left side, minus VA minus 2 VA is equal to, it is minus V naught, bring this 10 to right side, minus 10. Therefore, so here if you take the minus as common, then definitely it is V naught plus 10. V naught plus 10. Therefore, both side minus can be cancelled, and this is equal to 2 times VA is equal to V naught plus 10. Clear? This is the another expression. This is the another expression. Second expression from this node, right? Simply you can do one thing now. Either you can substitute equation 1 into 2, you can substitute either 1 into 2, or otherwise you can substitute 2 into 1. Both are valid, no problem. You can substitute anything. Therefore, if you simply substitute those things in either 1 into 2 or 2 into 1, nothing wrong in that, then definitely what you will get, then what you will know, substitute this V naught value, okay, V naught, substitute equation 1, write that, substitute or by substituting equation 1 in equation 2, substitute equation 1 into equation 2, means wherever V naught is there, substitute 7 into VA, then from second equation you will get 2 times VA is equal to, what is V naught? 7 times VA, it is 7 VA plus 10. This is equal to, what is this actually? 7 VA, bring to the left side this, 2 minus 7 then definitely it is minus 5 VA is equal to 10. Therefore, VA is equal to how much? Minus how much? VA is equal to minus 2 volts. VA is equal to minus 2 volts. Means what we are getting actually, we have obtained the nodal value, the nodal voltage. So we have obtained the nodal voltage. Whatever initially we have imagined, assumed that VA, that nodal voltage. Now if you see that particular circuit diagram, okay, at this particular circuit diagram, if you observe that, okay, so you can write that IL. So for finding the IL is equal to nodal voltage VA by what is that? 200 ohms resistor. Clear? So if you see that particular circuit diagram, load current IL can be written as IL is equal to VA by 200. What is VA? Minus 2. It is minus 2 by 200. How much actually? 2 times 2 ones are 200, means it is minus 1 by 100. It is minus not 1 amperes. Minus IL is equal to minus 1 by 100 is 0.01 amperes, or otherwise you can also write that it is equal to minus 10 milliamperes. IL is equal to minus 10 milli. 10 is equal to 10 power minus 3, obviously equal to 0.01. 0.01. Okay, this is the answer. Therefore, IL is equal to minus 10 milliamperes. This is what the right answer for that question actually. Some ABCDs are given. So, this is one of the correct option actually. Likewise, we have to solve the given operational amplifier circuits, right? So, with this, I finish off today's presentation, and I hope that you understood well. And in the subsequent presentations, let us focus on some more questions which are being asked from the UPSC examinations, as well as exclusively from GATE examinations also, right? And request you all to give your observations and suggestions, and do not forget to forward, to send, to share these informations to your friends, right? So I hope that you got this information. Okay, so thanks for watching this video, and meet in the next presentation. Till then, have a beautiful day.